Good evening. I'm Spot On Weather meteorologist Matthew Euler, and welcome to this latest video on this Friday evening. Yes, it's Friday the 13th. I probably should have thrown an image up here on the main title slide of, Friday the 13th type imagery of some sort of superstition or something. But instead, today, I'm looking at, I gave a great thought of titling this video. I titled it Windows. And the reason I titled it Windows, as you can see here in the image here, this photo, you know, we are entering that window of opportunity for winter weather across the mid-Atlantic as we're heading now, getting very close to mid-January, and then we'll be working our way right into that prime window in which we typically see some sort of wintry weather across the mid-Atlantic. We have the cold enough temps. I wrote up a weather blog yesterday that I posted on the Spot On Weather Weebly website. If you get a chance, check it out. I wrote a blog with the same title, Windows. So let's go ahead and talk about what's going on. The first thing tonight in the video, I'm kind of changing things up here. I want to start tonight's video off with talking about the late winter forecasting considerations. What are we looking at from this point forward to the rest of winter for forecasting considerations? And the main four I'm going to start tonight's video off with and explain a little bit more in detail is the La Nina rate of weakening. That's my first forecasting consideration. The Madden-Julian oscillation, or the MJO phase and magnitude. Now keep in mind that MJO is typically associated with 8 different phases, 1 through 8, and it has to do with where that tropical convection, where the enhanced rainfall is occurring across the equatorial tropical areas from the western Pacific Ocean to the Indian Ocean. Additionally, we need to examine the stratospheric polar vortex forecast and its potential impacts for the remainder of the winter. And then finally, I'll talk a little bit more about the teleconnections forecast and potential impact. So these are the 4 main factors or considerations I want to take into account in tonight's video. So let's start with these first. We're going to take a look at the La Nina comparison. Now, the graphics here on the left, the upper left here and the bottom left, the left-hand side of this slide, these are the water temperature anomalies as well as the Nino 3.4 region water temperatures in degrees Celsius, how much above or below normal they are is the bottom left-hand graphic here. And then on the right-hand side of this slide, the right-hand graphics show today, January 13, 2023, and show the same images side by side so we can do a comparison. All right, so let's just start with the sea surface temperature anomaly chart here. Blue coloring indicating below normal water temperatures, and the orange coloring indicating above normal water temperatures. All right, so back on the 20th of December, before Christmas, a few weeks ago, we saw the below normal temperatures extending from the west coast of South America right on across the equatorial areas all the way out to the Central Pacific. Okay, very clear signature here of a La Nina. Up in the North Pacific, we have these orange colorings indicating above normal water temperatures. And we did see a little bit of cooling on the 20th of December in the Gulf of Alaska, right along the west coast of Canada, right down along the west coast of the United States as well. So these are the main features I want you to pay attention to. Let's go to the right-hand side here. Now, this is today. And so notice now how it seems that we're seeing warming off the immediate west coast of South America. Notice how more extensive the blue coloring was here. These below normal water temperatures were in the eastern equatorial Pacific back on the 20th of December. Fast forward to today and look what's going on here. We're seeing a little bit more of the oranges and the lighter coloring here across the eastern Pacific. And we're seeing the main focus of below normal temperatures now, mainly across the central areas of the equatorial Pacific. So I noticed that change. Really not much in the way of changes here across the North Pacific. We still see above normal water temperatures today as compared to a few weeks ago on the 20th of December in the same general areas, right? We do see the cooler than normal water there, below normal water temps there along the Gulf of Alaska, again, on the south coast of Alaska, right on down the west coast of North America and Canada and parts of the Pacific Northwest. But really, we don't see a lot of changes outside. The really big one is the aerial coverage of the La Nina and how it seems to have shifted closer to the central equatorial Pacific. Additionally, let's look at the Nino 3.4 water temperatures, how above or below normal they are. And this was 20 December. We were sitting at a value on the 20th of December of minus 1.18 degrees Celsius below normal water in the Nino 3.4 region, generally here in this location across the eastern equatorial Pacific. And now let's look at today's, what value we're at today. We're at minus 1.058 degrees Celsius. So we have seen some warming over time in that Nino 3.4 water area, the water temps. So it seems like things are starting to fade more and more with each passing week in the La Nina area. So I wanted to start off with this first. Now let's move on to the Madden-Julian Oscillation, the MJO forecast. All right, so these are the latest forecasts for the MJO, starting with today's date, Friday the 13th, going all the way out to the 27th of January. All right, so the graphic here on the left is showing the Jeffs V12 forecast, showing, look at the red line here, showing it generally around today's day, between the 12th and the 15th, and that inner smaller circle of the MJO phase diagram indicating minimal impacts, null phase. And then it comes out the 17th, and then the 19th, it comes slightly out of that small inner circle, indicating some minor impacts due to the MJO moving into phase 2 and then potentially into phase 3, a little bit stronger, a little bit further away from that smaller inner circle there, indicating greater magnitude by the end of January, potentially into phase 3, where we see convection or the enhanced rainfall in the Indian Ocean when we're talking about phases 2 and 3 of the MJO. That's the Jeffs V12 forecast. Now the middle diagram here shows CFS V2, extended outlook from today, the 13th of January, to the 11th of February. Very similar here with the red line, showing it mainly in the null phase here, the small inner circle at the center of the diagram, working its way out though and becoming stronger into phase 2 by the 27th of January, and then really extending out the furthest point away from the small inner circle here, greatest magnitude around the 31st of January, before starting to work its way a little bit, weaken a little bit in magnitude, and then working its way towards phase 3 by the first week of February. Now that's the CFS V2 forecast, climate forecast system. Now what about the forecast here on the right? That's just the European model. The dates from today, the 13th of January, right on out to the 27th of January, very similar to the Jeffs V12 as far as the time range for 2 weeks. Showing, again, very similar. They're all in general agreement where it is right now around mid-January in the small inner circle here. So not much in the way of impacts from the MJO or influence. And then you'll notice how the MJO works its way out a little bit further from the small inner circle here on the European forecast. By the 21st to 25th of January, it's rotating into phase 3. But it's not a very strong phase 3. The magnitude isn't as great. So in summary, for the MJO forecast, the MJO is potentially heading towards phases 2 and 3 per these models. Each of these models is showing some kind of rotation towards phases 2 and 3 where we have enhanced rainfall in the Indian Ocean. The European and the Jeffs forecast, the graphic here on the right and the graphic on the far left, are showing similar trajectories and magnitudes. The outlier here is CFS V2, which shows a greater magnitude to the MJO. Okay, so we look at that. And these are the temperature composites. So let's say that these forecasts are right as far as trajectory of MJO into phases 2 and 3. These would be the temperature composites for the MJO phases 2 and 3 for the months of January, February, and March. You see blue coloring that generally indicates cooler than normal temperatures, and this yellow coloring that generally indicates warmer than normal temps. So in phases 2 and 3, this is right off the NOAA Climate Prediction Center site showing slightly cooler than normal temps across the east in phase 2, and then also cooler than normal temps in phase 3. Now, if we keep rotating through this MJO phase, and let's say we start rotating to 4 and 5, where we have convection in the maritime continent, that would favor substantial warming across the eastern U.S. Okay, I don't have them on here, phases 4, 5, and 6, and what the temperature composites look like, but you definitely can find the information at the Climate Prediction Center website. If you're interested, you go to the MJO link on the main homepage of the Climate Prediction Center, and you can actually go to the composites link and see those changes between the phases as far as what type of temperatures typically occur with each of them. All right, so now let's move on to the stratospheric polar vortex forecast. Now, this has been the talk of the town. All right, we had a fairly weak polar vortex in the stratosphere in the month of November. In fact, we had an elongation similar to the one we're seeing this weekend back in late November. It really didn't seem like it was getting its act together for a while as we headed into the fall. But then once we got into December, the stratospheric polar vortex strengthened dramatically, and it also repositioned itself over the polar area, the North Pole area. Whenever the vortex gets stronger, that tends to lead to milder temperatures in mid-latitudes where we live. But now things are changing with the shape. I'm always interested in the shape, and of course the strength of it's just as equally important. But let's take a look at the various models in their stratospheric polar vortex forecast coming up. Again, I want you to pay attention to the shape here, starting with tomorrow, 14 January 2023. See the purple coloring? These are your coldest temperatures in the stratosphere. Look how the shape of this generally extends and it looks more elongated, right? See how it extends down to the eastern United States? All right, so we're starting off with a polar vortex that's stretched or elongated. As we move ahead now in the GFS stratospheric polar vortex forecast for 22 January, we're moving it ahead about 8 days. Notice what's happening up here. Now, whenever you see the whiter coloring here, the white colors indicate warming temperatures in the stratosphere. And I probably can't read these temperatures on the scale, but anything with this darker orange or this white coloring indicates extremely warming temperatures in the stratosphere. Okay, we call that event a sudden stratospheric warming event. And the coldest temperatures by the 22nd of January are generally located over central Canada, with an extension or elongation of the polar vortex out over the North Atlantic. So we're going to go from an elongation into the eastern US this weekend, specifically tomorrow, the 14th of January, and then it's going to pivot toward the northeast, the whole elongation of the vortex, away from the east coast. Now, the GFS forecast midday run for the polar vortex showed this by 25 January. You still see this lighter white coloring that indicates extremely warm temperatures in the stratosphere over the North Pole area. And look at this deep purple here over the eastern US. And again, it's an elongated look. It's a stretched out look to the polar vortex over the east by 25 January. Let's move ahead now to the Jeffs forecast for the stratospheric polar vortex. Very similar for 14 January tomorrow, showing that elongation. See the purple colors, how it just the shape of this general outline of the purple coloring in general, an elongated polar vortex. By the time we get to 22 January, according to the Jeffs forecast, it's showing, let's compare. So very similar shape to the GFS forecast, see that? But much colder temperatures, or let's just say wider coverage of colder temperatures. See how the purple shading is delegated right to the top of this elongated shape here on the GFS forecast over central Canada is where the coldest stratospheric temperatures are. Look at it here on the Jeffs. They extend a little bit further to the southeast, generally over Greenland. And then by 25 January 2023, we still see that elongated shape of the polar vortex. And we also see the signature of warming. 22 January, look at the warming in the Jeffs model, the white coloring here. And look at it over here on the far right graphic, 25 January. So the vortex is definitely being disturbed. This is going to result in a general weakening of the vortex in the stratosphere. Let's look at the European model forecast from midday to day, the 13th of January. For tomorrow, showing a very similar shape, elongation occurring into the eastern US. And then by 22 January, very similar orientation, right? They're all generally in agreement out through 22 January as far as the orientation of the stratospheric polar vortex. It's elongated and it's basically going to pivot to the northeast, away from the east coast of the US, and out over the North Atlantic. And all the models are showing it. GFS, Jeffs on the 22nd of January, as well as the European model. So we have good agreement in the stratospheric polar vortex forecast from these models right on through the 22nd of January. If we compare the 25th of January, the shape is, a little bit different. Well, no, actually, this doesn't go out that far, but if I were to compare the Jeffs and the GFS, very similar shapes, the GFS just has the coldest stratospheric temperatures over the New England area, whereas the Jeffs is further south of Greenland over the North Atlantic. So bottom line here is we're going to see a weakening stratospheric polar vortex. Now, the degree to which this occurs, or how severe of a warming or significant of a warming we see in the stratosphere, those sudden stratospheric warming events, is going to be very important for our weather here at the Earth's surface. I'm going to break that down right now. By the way, all the next 3 slides, this data is courtesy of an article written, and I have the link here to the article if you want to take a look at it yourself. This article was written by Kretschmer, Judah Cohen, Matthias, Runge, and Como. All right. And so I'm taking notes directly from that source, from this article. I was doing a little research on the stratosphere earlier this week. All right. So there's 2 main types of sudden stratospheric warming events. The first one I'm going to talk about is absorbing sudden stratospheric warming events. There's also a reflecting sudden stratospheric warming event. And then I'll end it with a split, a talk on polar vortex splits versus displacements. So let's start with the absorbing sudden stratospheric warming event characteristics. These are the general results of when the wave activity from the troposphere, it gets absorbed into the stratosphere. This is what you generally get. You get several weeks of this troposphere. That's the layer of the Earth where we live. That's where all the weather occurs, right where we live, here in the troposphere. You get several weeks of troposphere-induced upward wave activity fluxes, and that is absorbed again in the stratosphere. Okay, I kind of hinted at that already. So you get several weeks of this, what we call coupling, between the troposphere and the stratosphere. You get increased temperatures with absorbing sudden stratospheric warming events over the polar cap, and you get a weakening of that zonal mean flow. Additionally, you get a negative Arctic oscillation, a negative NAO, which migrates downward to the troposphere over time, and this can persist up to 2 months. That negative North Atlantic oscillation and the equatorward shift of the polar front jet stream occurs. So that's when the jet stream shifts further south, and that allows colder air from the Arctic to start working its way down towards the United States, the mid-latitudes. It could be Europe as well. And in this case, with absorbing sudden stratospheric warming events, we see cold air over northern Eurasia, and it has less of an influence on North America. All right, so this is absorbing sudden stratospheric warming events. Again, here are the authors of this really good article. Now, what about a reflecting sudden stratospheric warming event? With a sudden stratospheric warming event that is reflected, it's going to be reflected it goes from the troposphere, reflected off the stratosphere. You generally get shorter pulses of vertical wave activity flux, so shorter pulses of energy from the troposphere to the stratosphere. You also get, with reflecting events, quickly recovering stratospheric flow. The reflection of upward propagating waves is brought back downward to the troposphere, influencing our weather patterns here where we live in the troposphere. And typically with the reflecting event, you get ridging, upper level ridging, or high pressure over the North Pacific. And that's associated with something known as a negative Western Pacific oscillation. That's one of the teleconnections I rarely show in my videos, but there is a relationship between this Western Pacific oscillation as well as that ridging over the North Pacific in association with reflecting sudden stratospheric warming events. Now, let's talk the difference between splits versus displacements of the polar vortex. So generally on average, when you get polar vortex splits, they generally tend to occur 50% of all sudden stratospheric warming events, and they generally have a surface response appearing in just 2 to 3 days after their onset. So I really don't have any graphics to show you an example of a split, but just imagine there's 2 specific lobes from the polar vortex itself that have split off from the main polar vortex, and as soon as that occurs, you get a surface response in generally 2 to 3 days where we live after the onset. Now, split events correlate with positive temperature anomalies over eastern North America, warming over eastern North America, and then negative temperature anomalies, colder than normal temps over Europe. So see, that's the thing with the split. The surface North Atlantic oscillation becomes strongly negative additionally with splits. With displacements, on the other hand, if the polar vortex is just displaced off the pole and becomes elongated and weakened, it generally leads to colder air outbreaks over North America. So splits versus displacements, there is a difference here, and this is per the research conducted by the authors down here that I have mentioned, as well as the article, the link to the article. All right, so now let's take a look at the teleconnections forecast. Moving into the fourth main consideration we have to talk about for the upcoming forecast period, as well as my thoughts for the remainder of the winter. European EPS AO 50 perturb members here on the upper left, showing the Arctic oscillation negative, pretty much negative through about the 21st of January, and then it kind of rides neutral until about the 24th of January, and then goes slightly positive after that. The last week of January, the AO is slightly positive. Upper right here is the EPS and AO 50 perturb members, generally showing a dip to negative for the NAO just briefly, 17th to the 19th of January, and then it goes up slightly positive from 19 January right on to the end of the forecast period, 28 January. Bottom left showing the Eastern Pacific Oscillation Forecast, European EPS 50 perturb members, starting off very positive, pretty strongly positive actually, from the 16th to the 18th of January, and that's going to coincide with a warming trend and general deepening troughing over the western U.S. and the eastern Pacific. And over time, though, the EPO does dip below negative again after the 22nd of January. So this will be something to watch in the long run, because whenever it goes negative, EPO goes negative, then you get an upper level ridge to build up into Alaska, general East Pacific. Finally, bottom right showing the European EPS PNA, Pacific North American Pattern, 50 perturb member forecast. A positive PNA to start from today, the 13th, right to about the 16th, Monday, January, 16 January on Monday. And then it goes generally neutral to the 20th of January. Kind of still rides neutral line all the way to 23 January before dropping negative. All right. So in summary, AO forecasted to be, maybe slightly positive towards the end of January, but fairly close to neutral, not super strong positive. The NAO also forecasted to be mainly neutral to slightly positive. The EPO over here in the bottom left, strongly positive right on through about next Thursday or Friday, the 20th of January, and then it's going to drop negative. And the bottom right the lower bottom right here showing PNA, positive to start, but then neutral, and then dropping potentially negative. So now let's take a look and examine the latest forecast charts, starting with tomorrow, the 14th of January, 2023. All right, so I'm showing the European EPS 500 millibar level here. Troughs are in the purple coloring. The ridges are in this brighter orange coloring. Okay. Ridges associated with fair weather, generally dry weather, and milder temperatures. The troughs, where you see the blue coloring and the green shading, they are usually associated with unsettled weather, some form of precipitation, usually storm development, and colder than normal temps. Right, so for tomorrow, Saturday the 14th of January, we see a deep trough across the eastern U.S. We see an upper level close low at 500 millibars over North Carolina. And that will allow, the upper level dynamics will allow for the kickoff of another surface area of low pressure off the mid-Atlantic, which will deepen and then just continue to kind of parallel the coast for a couple days before heading out to sea. But in general, we got a trough tomorrow. You see the thickness lines here on the right, see the blue dash lines. Anytime you see blue dash lines, the colder the temperatures are at the surface in the wintertime. And then, the lower the values, the colder the temperatures as well. So in general, what we have on the thickness chart, you kind of see some rising heights here over the northern plains in association with this upper level ridge over the northern plains and upper Midwest for tomorrow. But downstream of that, we have the deep trough off the East Coast, and that's going to result in a very cold day tomorrow across the mid-Atlantic. We also still see some troughing, another digging trough off the Pacific Northwest tomorrow. Moving ahead to Monday, 16 January 2023, we see the trough now that was over the East Coast tomorrow on the 14th of January. That moves offshore, generally just to the east of Martha's Vineyard there, Cape Cod area, Massachusetts. We do see higher heights and ridging generally across the North Atlantic, with the highest heights extending generally to the southwest of Greenland over eastern Canada. And we still see that troughing that's going on here. See this? That's in association with that positive Eastern Pacific oscillation. We got troughing along the U.S. West Coast. We have a little bit of weak ridging here over the East Coast by Monday, which is going to allow things to moderate as far as temperatures go. We'll see a surface high pressure system generally move offshore over the western Atlantic. That'll turn the surface winds around to the south and southwest, which will generally allow milder temperatures again from the Ohio Valley to the East Coast by Monday. We'll start having a modifying air mass. Look at the thickness chart over here. Notice the red dashed lines now are basically have moved north. In other words, our thicknesses have rebounded nicely by, this is Monday morning on the right. We do have an area of low pressure across the central U.S., eastern Nebraska, and we do see that moisture associated with that storm, another storm coming ashore in Northern California. That's a 992 millibar pressure center coming in, that low pressure into Northern California by Monday morning. Looking ahead now to Wednesday, the 18th of January, 2023, showing ridging still influencing the eastern U.S. It's not really strong ridging, but we have higher than normal heights from the Midwest right to the East Coast. And whenever you have those higher than normal heights, that's associated with milder temperatures, okay? You see the deep troughing here over the Four Corners region of the U.S. by Wednesday morning, the 18th of January. We see another trough now that's dropping down along the west coast of Canada. And additionally, we see those higher than normal heights now. We have a little bit of a ridging situation there building towards Greenland by next Wednesday, the 18th of January. So these higher heights here, we'll have to keep an eye on these as far as the positioning of those. But in general, we're looking at ridging, predominantly southwest flow across the mid-Atlantic by next Wednesday, which will keep it mild. If you look at the thickness chart, that corresponds well to the upper level chart here on the left, but the thickness chart here on the right showing the storm activity now moving into East Texas with some rain in Oklahoma by next Wednesday morning. There in association with that shortwave trough. And then we do see generally dry conditions across the mid-Atlantic next Wednesday morning. Moving ahead now to Friday, the 20th of January, 2023, we're starting to see a little bit of a pattern change according to the European Ensemble Prediction System, the EPS here. We see a subtropical ridge located over Cuba, centered over Cuba, but the orientation of the subtropical ridge is to the northeast, not from south to north up the east coast. It's now being squashed or kind of flattened a little bit as we see a little bit of troughing now moving into Pennsylvania and Ohio and West Virginia by next Friday morning, the 20th of January. We still see this troughing over the Four Corners region of the U.S., but we are seeing changes now by next Friday off the west coast, off the Pacific Northwest. We're seeing height rises or a ridge developing now. We see this trough. The trough now is further to the west, and the heights are now building downstream of this trough. Let's take a look at this. Just pay attention to this area off the Pacific Northwest. The coast, see how it was dominated by lower heights on Wednesday, the 18th of January? Those greens and light purple colors are now being replaced by these orange colors by next Friday. So heights are rising across the west, right on up into western Canada with the ridge axis. Downstream, you got the trough over the Four Corners region. You have a little bit of troughing here over New England, and this subtropical ridge is being flattened a little bit. We look at the surface precipitation and pressure patterns along with the thickness lines, showing a frontal boundary, just basically in the vicinity of the mid-Atlantic, with lower thickness values, these blue dashed lines to the north and the cold side of the front, and then the red dashed lines indicate milder temperatures and higher thickness values across the deep south by next Friday morning. You do see the dipping of the lowering of the thicknesses in association with this colder upper level trough across the Four Corners region. Now let's move ahead to the forecast for Sunday, the 22nd of January, next weekend, showing a big difference, a big change in the pattern. Look at this. Blue coloring indicating lower than normal heights extending from Texas right to the mid-Atlantic. And now look at this ridge. Now we have a closed upper level high situated off the Northern California coast. And this pattern change is going to give the folks in California a much needed break from all that storm activity and all that flooding that's been happening. So this is good news for California because you guys kind of need a little bit of a breather after these last few weeks of just getting storm after storm coming in. So big changes on the way in the upper air pattern by next weekend as we see this upper level ridge, these building and the heights rising more significantly. Look how deep the orange colors are now compared to this one on Wednesday, or Friday rather. Next Friday, the 20th of January, look at how lighter colored the orange colors are. Those heights aren't as high, and now they're even higher at this point. So this upper level high is in a good position. We'll get rising heights all the way up into the Yukon territories. Downstream of that, you have deep troughing trying to develop now from the central U.S. to the East Coast. Look at what you got here on the European operational model today. Whoa, 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 what is this? Now, I know it's going to change, but this is a nice look if you're looking for, potential winter storm across the eastern U.S. and the East Coast. At this point in time, it's a fairly strong surface low pressure system off of Cape Hatteras. And we do have some colder air trying to filter in toward the mid-Atlantic. At the same time, you got a lot of vertical lift going on and moisture. So something to watch and something to keep an eye on. It's no guarantee. We're talking pretty far out in time right now. 10 days, almost 10 days out in the future. So, but interesting, let's watch these ensembles. Let's see what happens. Now let's turn our attention to the temperatures and the anomaly, the high temperature anomaly forecast on the right. So I have temperatures left, high temperatures on the left, and then high temperature anomalies on the right. So this is for Saturday, the 14th of January, 2023 tomorrow. We have that deep trough as we already examined. And within that deep trough, we have much colder air filtering in from eastern Canada. So it's going to be a cold day across the mid-Atlantic. High temperatures in the lower 40s across a good chunk of Virginia. And then you get up towards Pennsylvania, your highs are now in the upper 20s to low 30s. Across the Ohio Valley as well, high temperatures generally in the low 30s. And so it's pretty cold. And then look at Florida down here tomorrow for high temperatures. Highs only 50 to 52 degrees Fahrenheit, 52 in Orlando. It's going to be a chilly, chilly day. If you look at the anomalies over here on the right, you're seeing where the greens and the blues indicate below normal temperatures, and then the bright orange is indicating above normal temperatures. So in association with the upper level ridge over the northern plains, you're seeing above normal temperatures for tomorrow, and you're just seeing below normal temperatures. Look at this, 18 degrees below normal, 18 degrees Fahrenheit below normal in central Florida tomorrow for their high temperatures. So it's going to be a chilly, chilly day for Florida. Looks like they have the greatest temperature anomalies for tomorrow. Looking at the forecast, the high temperature forecast here on the left for Monday the 16th of January, we still see some fairly chilly air, but the air mass is now beginning to modify along the eastern seaboard. Notice this yellow coloring here. That's indicating that milder air trying to move up the coast now into parts of North Carolina, the coastal South Carolina, back up to 60 degrees by Monday. And then generally the coldest temperatures are going to be now located over parts of North Dakota, Montana, Wyoming, out west. See these colors out here? These indicate colder temperatures in the western U.S. for Monday the 16th. How warmest temperatures are going to be down around Texas, where your highs are going to be 75 to 80 degrees in Texas on Monday. And look at this, temperature anomalies from Texas all the way up into the Midwest. And this brown coloring here over Iowa and Missouri indicating temperatures 25 to 30 degrees Fahrenheit above normal by Monday. Generally close to average along the mid-Atlantic coastal areas, still slightly below normal across Florida. And then look at the green coloring here in the southwestern U.S. and the parts of California. This is where the coldest, most below normal air is going to be located, 10 to 12 degrees Fahrenheit below normal in these areas you see in green. Looking at the forecast now for next Wednesday, the 18th of January, things have got much milder now up into Virginia. See this? 60 to 65 degree Fahrenheit temperature forecast high temperatures for next Wednesday. And then you see this line here dividing the yellow color and the purple coloring. That's where you have your next cold front. However, this front's not going to be very strong. So don't expect this cold front next Wednesday to be the same type of cold front that's moving through this weekend. And look at how warm it is across the Midwest to the East Coast by next Wednesday. A wide swath of 10 to 15 degree Fahrenheit above normal temperatures, all the way up to Maine. The coldest temperatures remain over the U.S. Southwest, as well as parts of California and Nevada, parts of Arizona by next Wednesday. And then next Friday, the 20th of January, still very mild conditions. Virginia southward down I-95, generally in the 60s, 70s in Florida. And then we have colder temperatures generally north of this baroclinic zone, which is stretched along the Ohio River by next Friday. The rose colors here indicating high temperatures only in the 20s across the upper Midwest, Minnesota, and the Dakotas by next Friday. And then the warmest temperatures are going to be along the Gulf Coast. Here are the anomalies on the right for next Friday, the 20th of January, showing the greatest warmth from North Carolina, Virginia, working its way north towards Maine. And look at this green coloring and blue coloring. That indicates 10 to 15 degree below normal temperatures across the western U.S. for next Friday. Now, let's look at the longer range temperature ensemble forecast. This one goes out to 25 January. I'm showing the GEFs on the left, GFS ensemble, and then the European ensemble on the right. All right, so we had much more hope when we got to the last week of January. I looked at the charts a few days ago, and the blue coloring, the lower than normal heights, were all the way to the East Coast by this point. Now we're starting to see the subtropical ridge here trying to extend a little bit further to the northwest, according to the Jeffs model here on the left, by 25 January. Above normal heights all the way up and down the East Coast. The below normal heights are across the central U.S., the northern plains, even extending back towards Colorado, Wyoming, and Montana, and then you have higher than normal heights across the Northeast Pacific. Look here on the graphic on the right. This is the European ensemble forecasting system showing a stronger upper level ridge off the U.S. West Coast by this will be Wednesday the 25th of January. We have a downstream trough, but then we have this ridge, the tropical ridge over the Atlantic, trying to extend northwestward. So the coldest temperature, lowest heights will be over the Midwest by the 25th of January, according to the European ensemble. So we're starting to see more of a higher height tendency here along the East Coast again as we head towards the last week of January. Okay, so here's my final thoughts on tonight's video. I've covered a lot of material, and I'm going to summarize it over the next 3 slides. All right, La Nina is continuing. We're still sitting at the moderate level of La Nina, the moderate strength La Nina, but we're noticing those temperatures starting to warm more and more with each passing week in that Nino 3.4 region. So La Nina is weakening, folks. That's for sure. Now the MJO is headed towards phases 2 and 3. That would indicate enhanced rainfall phase or convection in the Indian Ocean. Now the magnitudes do differ with respect to Jeffs and European models. They show weaker MJO magnitude as compared to the CFS V2. MJO phases 2 and 3, as I showed you, favor just generally cooler than normal temps across the U.S. overall, per those temperature composites I showed, the January, February, March composites. Now, the stratospheric polar vortex, it's expected to weaken in some form. Now, to the extent it weakens, it still remains to be seen. And we are expecting that polar vortex in the stratosphere to become displaced off the North Pole. Now, some models, especially looking at them today, the GFS in particular, is way more bullish with a significant sudden stratospheric warming event and overall polar vortex split at the end of January. I can't discount GFS entirely, but I would like to see all the models generally in agreement with this scenario. And we're still 2 weeks out from that point in time, so at this point we're just going to monitor the trends on that stratospheric polar vortex forecast. I talked about the differences per the research that I shared, that link between a polar vortex split versus a displacement, and it is a big difference. Where does the coldest air end up? Does it go to Eurasia, to Europe? Does it come to North America? And if so, North America, where does it go? To the western U.S.? Or does it come to the eastern U.S.? That's going to play a huge, huge, huge role in the late winter season weather. All right, teleconnections, as I showed from the European EPS, they're sending mixed messages right now. For example, we looked at the forecast for a negative EPO, Eastern Pacific Oscillation, after 22 January, but a negative PNA, okay, for the same time period. Now keep in mind, a negative EPO is going to favor an upper level ridge over the Northeast Pacific, extending northward to Alaska. But a negative PNA is generally going to favor troughing specifically over the western portion of North America. So this is what I refer to when you have a negative EPO but a negative PNA. That would be indicative of destructive interference potentially between those two teleconnections. The AO, the Arctic Oscillation, the NAO, North Atlantic Oscillation, are straddling neutral pretty much through late January. Now, I did show you some tendencies of the AO and NA to go slightly positive, but it's not eye-popping positive, okay? Now, we are going to see the deep upper trough this weekend, 14 and 15 January, in the eastern U.S., and that's going to give way to zonal to weak upper-level ridging across the mid-Atlantic. early next week, specifically Tuesday time period, that's going to result in a return to above normal temps in the mid-Atlantic and the eastern U.S. as a whole. Now, the ensembles are indicating a turn to lower heights and potentially colder temps across the eastern U.S. around 22 January, but they are showing upper level ridging extending to the northwest from that subtropical ridge off the southeast coast. That is, the ensembles are showing that now, which would indicate milder temperatures again the last week of January. So we're going to have to watch that closely. And then finally, this is really what goes through my mind. These are the real questions for the long term. Really, for the long term forecast, potentially the remainder of the winter season into February. All right, what's the phase and magnitude of the MJO going to be? Will the MJO become stronger and have a greater influence on the upper air pattern for the U.S.? That's a big question mark. That's a big question mark. If we go back real quick, and we look at this again, let's go to the MJO forecast. All right. So the JEPS V12 and the European model are generally in the same boat. They're not going very strong in magnitude. In other words, these forecast lines aren't going like way far off the chart away from the center of the diagram. All right, so European and JEPS V12 showing a weaker magnitude MJO, even though we're going into phases 2 and 3 with enhanced rainfall in the Indian Ocean per the forecast by late January. CFS V2, honestly, it really doesn't have a very good track record, so it's showing some much more significant amplitude or magnitude into phase 2 of the MJO. I really would bet more money on the JEPS and the European, vice the CFS V2. So, the big question for us, how much of influence does the tropical convection have, the Madden-Julian Oscillation, through the rest of winter? The rate of La Nina weakening, this will be critical. The sooner the La Nina dissipates, the less likely we will continue to see its influence on our weather pattern in late winter. This one's big. It's slowly weakening, but when does it reach the ENSO neutral stage? When are we officially done with La Nina? Is it going to be February? Is it going to be March? Is it going to wait till the spring in April? Remains to be seen, but we're watching this closely. This is a major factor of consideration in the remainder of the winter forecast. And then the stratospheric polar vortex, I cannot emphasize this one enough. It's a huge consideration. What this vortex does in the stratosphere, whether we see a significant sudden stratospheric warming event, a split vortex, or just simply a displacement off the North Pole and elongation. Okay? Typically, per research, splitting polar vortex events result in the coldest air being over towards Europe, not North America, whereas displacements or weakening or elongation of the polar vortex typically result in the coldest air in eastern North America. So just because you get a split and just because the vortex is weakening does not necessarily mean you're going to get cold weather in the United States. Not in all cases. Right. And then how do those teleconnections change over time? Will we see constructive or destructive interference in the teleconnections over time? Well, so with destructive interference, basically we're canceling out teleconnection effects. But with constructive interference, we're enhancing teleconnection effects, right? So let me give you an example of constructive interference. La Nina plus MJO in the warmer phases, let's say phases 4 and 5. That would be constructively interfering with each other. That would be producing milder temperatures in the eastern U.S., for example. Now, destructive interference example would be a La Nina, but a strongly negative NAO, which we had in December. All right. La Nina would indicate milder temps in the eastern U.S., whereas a strongly negative NAO should indicate colder temperatures in the eastern U.S. That's destructive interference between the teleconnections. Okay. So you have to examine the teleconnections. You have to see if they're working with each other or against each other. Are they constructively interfering with each other, destructively interfering with each other? What's the overall results of this process? How does this impact our upper air pattern, our jet stream, for example? The polar vortex, the same thing. How does the behavior of the polar vortex affect the positioning of the polar front jet stream as well as how far it dips south in lower latitudes. Um, it's going to be critical. You know, since our major cold event at Christmas time, and mainly in December, we had a lot of high latitude blocking in December, but it's really been absent with such a strong Pacific jet and La Nina. It's been interesting to watch. But anyway, as you can see, there's a lot of moving parts here, right? Whenever you're examining forecasts, there's a lot of moving parts. There's a lot of things to consider, and this vortex, the polar vortex, is just it's such a important piece to what happens the rest of the winter. Because if the vortex, let's say the models back off on the weakening, and it remains fairly strong the rest of the winter, and then we have La Nina still hanging on. Let's just say the MGA goes to warmer phases. Then we literally could be looking at a milder rest of the winter. But on the other hand, let's say the stratospheric polar vortex goes through a major weakening. That could be a game changer for February. So a lot still remains to be seen. I'm very optimistic. I like winter weather. I like at least one snowstorm a winter. But I'm not going to hang my head about what we got so far. It is what it is. And just remember, whenever there's a possibility, there's always hope. All right. So that's all I've got for now, everybody. I hope you enjoyed tonight's video. I'm going to run. And until next time, everybody, we'll be watching this closely to see what happens. Until next time, everybody, take care and God bless everyone.